Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about the overall network layer, that means overview of what a network layer is and what are the responsibilities of that and how it is going to perform the actual functions. So, before going to the lesson, I am expecting that the student will be able to know about the functions of network layer and also the services provided by the network layer, and also how the packet forwarding and switching is possible in a network layer and what are the challenges in the network layer. So, these are the things I am going to cover today. So, let us start with the actual functions of network layer. So, among the set of layers in the OSI model, that means from the physical layer to the application layer, there are several layers in between. So, application layer and followed by data link layer, network layer, transport layer, and after that the presentation layer, session layer and application layer. So, there are a number of layers which are actually proposed by the ISO people, and the model is called as OSI model, which is actually meant for the data transmission to be conducted successfully from the sender to the receiver. So, in that the network layer is the actual the third layer actually, which is responsible to look after the overall local network that is actually governed by the network layer. If you cross network layer, the next layer is transport layer above network layer, and which is responsible to actually look after the internet and its operations. So, that is why the network layer is limited to the local network basically, but of course, even then it has to say so many, it has to actually do so many activities which are actually listed like this, and among all these things the primary function is the routing. So, routing is a concept of deciding the best path for allowing the data to travel from the source to the destination, because if you are choosing the actual not a best path, automatically it will be very expensive, and during the transmission there may be loss of data. So, these are the problems you may come across if you are not choosing a better path or the best path. So, that is why the network layer is responsible by using some devices, it is going to decide what is the best path. That means best in the sense there are three important characteristics we have to consider to say that the path is the best path. The path should be economical, the path should be reliable, and also the path should be efficient. If you see all these factors are satisfactory, then you can say that the path is a best path. So, network layer is by using the router. So, there is a very important process that is actually be carried out by the network layer, that is called routing. So, which is responsible to transmit the data from the source to the destination in a best path and in an efficient manner. And there is one more activity that is identified here, that is called forwarding. So, in the network layer, so depending on several devices that are there in the network, actually the forwarding is a very important phenomenon which is to be followed by all the devices in the network. Forwarding means what? Suppose whenever the source is generating some packets and it is allowing to travel, then the subsequent devices has to take into consideration those packets, and they have to forward it to the neighboring devices so that the transmission can take place. So, that is why this forwarding is nothing but transfer of packets from an incoming link to the appropriate outgoing link, because incoming link is different from the outgoing link. So, the packets will be arriving from the incoming link, and they should be allowed to travel to the outgoing link. So, this is a process which is called as a forwarding. So, this is also the responsibility of the network layer to see. And the other one is called as logical addressing. This is another important point which is to be followed by the network layer, where logical means there is some point of identifying a device in the network based on some criteria. So, every device will have a unique address, and also the device can be identified by based on the the network in which it is actually placing. So, that is why the address is a very important thing. So, one is the device will have a fixed address, and also depending on the network, one more address will be carried out by the actual network, and that address is called as the logical address. So, logical address purely depends on the network. Suppose A is a device, let us imagine that A is a device which is in the network called N1. Then the address of A will be based on N1, the address will be there for the device A. Suppose the same device A is actually moved to another network called N2, let us say, then this address of A will not be same as the actual N1 once it is placed. When it is going to N2, automatically the address will change, even though the device address may be the same uniquely, but because it is changing its network from N1 to N2, it is going to get one more an address. That address is called as a logical address, that is purely depending on the network and its ID. So, this is the way how the network layer is responsible to actually focus on the logical addressing point. And the next concept is called as the packet fragmentation and reassembly. Network layer is also responsible to divide the entire message into number of packets. You notice the packet configuration only in the network layer, not above the network layer or not below the network layer. So, you see that the packets will be identified in the network layer, and the packets are depending on the message length. The packets will be actually derived from the message into proper determined length. So, based on that, so a message can have a number of packets. A message can be divided into number of packets. So, whenever this is happening, this is technically referred as packet fragmentation. So, once you combine all the packets, so automatically you are going to get the original message. So, if you divide the message into number of packets, it can be referred as fragmentation. So, here to identify the proper assembling of the packets, every packet will be numbered, and also every packet will be headed with some header, so that to whom it is to be delivered, from where it is coming. So, this is identified in the header part, and moreover every packet will be identified with a number, that is a serial number, that is called a packet number, so that you can able to assemble them in a proper order, so that the message will not change its order. So, that is why the fragmentation is one part of dividing the whole message into number of portions, whereas reassembly is generally be taken into consideration at the receiver, so that all the numbered packets will be assembled in a sorted order, so that the original message again can be identified. So, that part is called as, that means the combination of all or combining all the fragmented packets into a single one can be referred here as a reassembly. So, this is another important responsibility of the network layer, and there are some models that are to be followed by the network layer. So, those models can be called as network service models. So, in that there are two important things you have to consider. One is connectionless kind of a service and connection oriented kind of a service. There are two different types of services we can identify in the network service models. What basically the meaning of connectionless service? So, here it is actually referred as a datagram network. Here suppose you say that there is a message you have, and this message is divided into number of packets, let us say P1 to Pn, let us say. So, these are the messages, these are the packets from P1 to Pn, and when they are actually traveling in the network like this, let us say there is a source here and there is a destination here, and once the packet P1 is traveling in this network, which is actually by following different routes. So, the packet can reach to the destination from source to destination. All the P1 to P1 PN packets can travel in different directions, and finally they can reach the destination. This is called as connectionless service. That means there is no guarantee that all packets will travel in the same route. Depending on the suggestion that is made by the router, so every packet will individually or independently go in a different path, and finally their destination is D. So, finally they will they will be collected at the destination D. So, this is the way how the packets can travel in the network, and this is actually referred here as a connectionless service. Here is unreliable. That means you cannot say that whether all packets will go to the destination properly or not. There is no guarantee at all. So, that is why this is called connectionless service, and moreover this is unreliable, which is of course sometimes it is difficult to establish all reliable connection services. So, that is why better sometimes you can go for an alternative. So, in that case you can refer the connectionless service, which is also the responsibility of the network service model, which is basically called as a datagram network. And of course, there is one more thing that is identified here, that is virtual circuit network, which is shortly called as VCN, which is responsible to establish a connection before exactly transmitting the information in the form of packets. Let us say if you take the same example as shown. So, in this case of the VCN, so the source is releasing all the packets P1 to Pn, but of course, in this the VCN there will be a request that will be made by the sender to the receiver, so that whether the route to be established is possible or not with respect to of routers which are actually forming the network, based on the routers that are there in between the source and the destination, and the suggestion made by the routers. So, the S is first of all putting a request to the destination whether any route is possible or not to establish virtually. So, first once it is happening, let us say, then automatically the P1 to Pn all packets will follow the same route from starting from source to the destination. They all follow the same route. So, thereby you can say that virtually a circuit is established between the source and destination. So, that is why this is called as a reliable kind of a service, what we can call. And moreover, because it is virtual, and even though it is a virtual, but source and destination are partially connected on a temporary basis. So, this is called as a connection oriented service. This is also the responsibility of the network service model, by which the packets can travel from the source to the destination in a reliable manner. And of course, there are some routing concepts that are also being possible, you can identify in the network layer. So, in this one important thing is called as link state routing protocol. Link state routing concept is followed by the actual routers in the actual network layer. Generally, you find routers or switches in the network layer, so that they establish a network, and of course, in this to cover the whole network, so they have to follow certain protocols. So, in that in the link state routing protocol, based on the topology that the network actually been established. So, in this the actual the link state routing is going to follow a concept called as taking the information from the all the routers which are actually forming the complete network. It is going to, every router is going to take the information which is there in the all router tables, and based on that it is going to update its routing table. So, that based on all the information that is collected from various routers, it can able to decide which is the shortest path, and it is going to suggest that path to the packet to travel, and that is the main criteria you can identify in the link state routing kind of an algorithm. So, this is a very useful algorithm by which you can able to allow the packets to travel in the shortest path. So, that is why this is a very important algorithm. In this, the routers are going to share their information totally, which covers the whole network, and the routing table will be updated periodically. Based on that, the shortest path can be derived, and based on that, the packet can travel from source to the destination by following the shortest path. And the example is a Dijkstra algorithm. This follows whatever the concept I mentioned. It is going in the algorithm, Dijkstra algorithm, you are going to see the main criteria. And of course, there is one more routing criteria that you are finding, and that is called distance vector routing algorithm. So in this, the routers are not going to share their information totally. So in this, every router is allowed to share the information from its neighbors only, So that is a basic change between the earlier concept and this one. So in that earlier concept, every router is going to get the information from all the routers, but whereas in this case only from the neighboring routers the information can be gathered. So that is the basic difference in this, and that is why this is called as in the distributed scenario. So every router can able to get the information from the neighboring routers only, not actually the all routers that are there. So it is only going to get the information from the neighboring routers. Based on that, it is going to update its table. So that is why this distance vector routing algorithm, so it is a very informative kind of a thing. That is why, so that is why RIP is a short form of routing information protocol. In that, the protocol, in the sense, it is a rule. What is actually the rule is, every router can able to share the information to its neighbors only, not to the total network. So that is why it is a protocol. So based on that, the path can be established, which is actually directed by the router. So based on that, the packet will travel, so by exchanging the information in the form of a packet. So that is about distance vector routing. There is hierarchical routing, which organizes network into regions for scalability. So suppose you are actually going to use a huge network, then it is very difficult to manage the huge network even by by following certain protocols. Then better for scalability, that means to know what actually that is happening. So better you can divide the overall the huge network into smaller regions. So thereby you can handle, thereby you can able to measure what is happening in the total scenario. So that is why this is another important point, we can call it as a hierarchical routing. And there are certain things you have to consider, how the packet will be forwarded and how the switching is going to play an important role in this. So there are three kind of techniques that are actually being identified. One is called store and forward kind of a technique, and another is circuit switching, and the next one is virtual circuit switching kind of a concept. We will see one by one. So in the store and forward, a router or a switch, more or less, a router and switch are the devices by which they can able to establish a temporary connection between the sender and the receiver, or between the devices. A switch is a device, router is also a device which can also work like a switch with a higher configuration. So that is why, but the basic concept of switch and router is to provide or establish a temporary connection between the devices. So that is why, while actually transmitting the packets from source to destination, first of all the router has to check whether the route is clear or not. If the route is not clear, if any kind of error is taking place, first of all it has to identify the path is clear or not. Suppose if the path is not clear, it has to first of all store the packets which is received by the router or a switch for some time, and later on once again, once it is noticing that the route is clear, then automatically it is going to release the packets which actually holded by the switch or a router. The releasing is referred here as a forwarding, but holding up the packets for certain information for certain interval is called as the storing. So this is another important feature you can identify, so that it will improve the efficiency of the transmission without any data loss. So that is another important point what you can say. So that is called store and forward. And the next one is called as circuit switching. In this circuit switching, what actually I mentioned is, so there is a dedicated physical path you can identify between the sender and receiver. Suppose A is a device and B is another device which are actually participating in the data communication, but here a dedicated physical path, a channel will be established between those two things, which is definitely a reliable kind of a service, and by using this automatically the packets will travel dedicatedly from source to the destination without any problem. So, this is actually speaking, this is difficult to establish because it is very expensive. So, that is why the circuit switching, okay, even though theoretically it is good to use, but practically speaking it is very expensive, but as a matter of switching, how it is going to take place, just it is only a dedicated physical path that is established between the sender and receiver for the entire duration for a communication session. And there is one more thing that is called virtual switch net, circuit switching. Here just what I mentioned is VCN. Earlier in the previous slide I mentioned that there is a virtual circuit that will be established logically, not physically. So, thereby every packet will follow the same route and finally reach the destination. So, the same point actually mentioned here once again. And what are the challenges in the network layer? Even though network layer is going to do so many things, functions, but even then there are certain things which are to be handled properly. One is called scalability, because network is going to establish, or network is not a fixed one. So, it goes on increasing depending on the requirement. So, it can extend it to any extent. So, that is why. So, you cannot manage directly by using certain principles. So, that is why it is a big challenge of maintaining or managing the network overall. So, that is why it is a challenge, big challenge, which is referred as a scalability, where managing of the large scale of networks is really difficult in this case. So, how it is possible to solve the problem? So, that is to be carried out. And next is security threats, because in the network once you put your packet, so you do not have any idea about where it is going, which direction it is following, any error is occurred or not, how do you identify that? So, that is why the protection of data is another important thing, because nowadays hackers are spreading over the whole the scenario. So, that is why protecting of data, protecting of valuable information is another important challenge to consider. So, that is why the security threats are very regularly we are finding out. So, that is why to overcome that, what actually we are going to take. And the third one is called as a quality of service. So, here because the network is not a fixed one, so it is not static, go on extending, it may extend or it may be sometimes some devices may add, sometimes some devices may be dropped in the network. So, that is go on in a variable fashion. So, how you can able to ensure the quality of the usage of the bandwidth, because sometimes you may go for a common channel with some bandwidth, how you can able to manage the bandwidth of the channel, so that ensuring that all the channels are actually, all the devices are getting equal share of the bandwidth of the channel. So, this is another important challenge you have to look after in this in the network layer. So, these are the challenges to be carried out in the network layer. So, that is why the network layer is basically a very important layer, which actually related to the local network, and there are even then network layer is having so many functionalities, but even then there are some challenges also to be carried out. So, that is about the network layer, and I hope that after completion of this lesson, so the students are able to know what actually the basic functions of the network layer, and what are the service models and what are the limitations of the service models also we are clear, and what are the basic techniques that are actually been carried out in the packet forwarding and switching concepts, and also what actually the challenges which are actually the burden in the network layer to follow and to overcome the burdens here. So, this is the thing. Thank you.